Hi everyone, and welcome to Jam Academy. The objective of this lesson is just to do a series of examples to illustrate how automotive power is measured. Now, before we go any further, power is the rate at which work is done. In other words, whenever work is done, energy is transferred. So we can as well define power as the rate at which the energy is transferred from one object or one system to another. In so doing, P is defined as dW over dt, or P is equal to dE all divided by dt. Now understand that W is equal to F dot delta R. So, which implies that P will be equal to F dot dr all divided by dt, and dr all divided by dt is just V. Hence, we can conclude that P is equal to F dot V, the dot product of force and velocity. That means that power itself is a scalar quantity, even though it can be positive or negative depending on whether the energy is transferred into or out of a system. Now, the unit of power is the watt. 1 watt is equivalent to 1 joules per second, which is equal to, remember that 1 joule is equivalent to 1 Newton meter, which is equivalent to 1 kilometers squared per second squared. Hence, this would mean that 1 watt is equivalent to 1 kilometers squared divided by seconds cubed. It's important you keep that in mind, divided by seconds cubed. We just demonstrate that the watt is a derived unit, and we have expressed the watt in terms of its base units, which is the kilogram, the meters, and the seconds. Now, the common unit to measure automotive power is the horsepower. Now, 1 horsepower, this is beautiful, 1 horsepower is equivalent to 746 watts. It's equivalent to 746 watts. Now, I would love to, talk about the historical origin of the horsepower, but it's not really essential here at this moment. Now, let's dive straight and look at a pretty typical example. Now, the engine of a car transmits power of magnitude P to the driving wheels when the car is traveling at a constant speed V on a horizontal road. Now, we are asked to determine the magnitude of the resistive force acting on the car. Now, before us, we have a car. Let's do our free body diagram. The weight of the car obviously acts downwards. The normal force on the car acts upwards. You have here, this is the traction force, and you have here, this is the resistive force. I'm just going to call that FD. You see, the purpose of this question is for us to be able to compute the resistive force acting on the car. And the car itself is moving with a constant speed. That is important because if the speed is constant, it simply means that the sum of forces acting on the car is actually 0. So we know that the sum of forces in the x direction will be equal to F minus Fd, which is equal to 0. This means that F is equal to F sub d. Now, we don't know what F is, but I'm going to show you how to calculate F. Similarly, the sum of forces in the y direction, this will be equal to n minus mg. This is equal to 0. This means that n is equal to mg. So the normal force acting on the car or the wheels of the car is just equal to the weight of the automobile. Now, by definition, the power transmitted to the wheels, P, which is what we could measure, is equal to the force, the traction force, multiplied by V. This means that F is equal to P all divided by V. And as a result, this would mean that the resistive force acting on the car is just equal to P all divided by V. Now, this right here, my friends, represents the resistive force acting on the car. Now, the question I want to ask is, what if the car wasn't traveling at a constant speed? How can we calculate this force? If the car isn't traveling at a constant speed, it brings us to one important point. One, we will therefore know that F minus F sub D will be equal to MA. Now, what is F? F is equal to P is equal to FV, which means that F is equal to P all divided by V. So this would imply that P over V minus F sub D, this will be equal to MA. Now, there are a series of things we can do with this particular expression. Now, I can ask you to calculate the velocity of the car as a function of time. Now, in which case, I may give you the expression for D, which is often BV, where B is a positive constant. Now, how can we go about doing that? If we substitute F sub D in this particular expression, we will have P over V minus BV equal to M dV all divided by dt. This is a beautiful equation that we can actually solve for V. Now, this was just an extra bonus that I wanted to show you. So please, if you have any questions regarding this problem, I will appreciate it if you ask in the discussion forum below this video. Thank you so much and have a wonderful day. Bye-bye.